There are n PG standing in a line number from 1 to n. From left to right, every PG is either facing left or right. Two PG X and Y are called a watch peak pair if X greater than Y. Y greater than X. X is facing right and Y is facing left. X is facing right and Y is facing left. Okay, and X, Y. Okay. You are given an integer case such that between n a pg is called safe if it belongs to at least k watching pairs. Your task is to make all piggies safe. To achieve that, you can choose any number of piggies and flip their direction. Okay, what's the minimum? Okay, so k okay belongs to a pair L R L R, and that's 3, and somewhere between n. Is there impossible? Yeah, there's impossible. Yeah, that one is impossible. This one is possible. Right, L L R R L. I need 2, so it's facing this side. So that's a problem. So it has to be facing this side. Right. It also has to facing this side, and this one, this one can face. Yeah. Right. Okay, I'm doing opposite. Right, left at this side. Right, right, left, left, right. Okay. So doing n square is okay, but let's see. Is it right? Correct position. These two obviously have to face this side, and these two are counting this one, and these two are counting this one. So I need at least this and this to make them good. Yeah, I think that's the answer. Answer is 5. I have to make them L. 1, 2. 1, 2. 2 here. Right. 1, 2, 3, and 3 there. Yeah. I don't get it. Why the n is really low, small. K is somewhere between n. There's a possibility they're overlapping. So K has to be at least K, at least K, 2K. If I want them to be right. Get an equal to what? I have a value n minus 1, n minus 1, n minus 2, n minus 3, n minus 4 case, let's say 3, so just n minus 3. Quite a long time to solve. Obviously I've done it in offhand, so that's that. You are given an array A of integer. Your initial score is 0. You can perform the following operation, two type of operation any number of time until the array becomes empty. Choose a string, single element, add its value to your score and remove it from the array. Choose two adjacent elements, add the maximum of the value in the score and remove both elements from the array. Okay, this operation requires got the point. After each operation, the remaining elements are concatenated without changing the you are also given an integer c which represent the cost to perform one operation. Every time you perform an operation, C is subtracted from your score. Compute the maximum possible final score you can achieve. You can perform the following any number of time. Okay, values can be negative, that makes sense. N and C is given to me. N and C is 0, so answer is 3, 1. Yeah, makes sense. If there is a negative value, I can easily negate that. Okay, and yeah, okay, why the answer is you can perform the following operation, following type operation any number of time until the array becomes empty. So why its answer is this negative something? Do I have to make the array fully empty? You can perform the following two type of operation any number of time until the array becomes empty. Okay, I think I have to remove all the values. It doesn't say that, but I think there's a mistake in the problem statement. So I'm subtracting 6 every time. So taking 9 is good. So adding 3. Taking 5 isn't. So I'll take just -1. So eventually I have 2. Taking 4 is also bad. Again -2, so 0. Actually I can take 9 and 3 together. That's why it becomes 0. So any value can be adjacent for any time. Minimum and maximum can be taken together always if those are what if the values are greater than 7? always taking single one is better. Yeah, always taking single is better. Is it? I'm saving one. If I'm saving something, it's always better to do some operation. Gave me 4 just because this one. It should be 5. What's going on? It doesn't make any change. I've broken as you should see. Okay. Okay, you are given a positive integer n and a non-negative integer k. Construct a permutation p of length and such that the following condition is satisfied. Let f of I equal to mix of 0 to I for every I, then f of 0x or everything. Okay. Okay. Should equal k. Where okay. Note that a permutation of length n is an array consists of n distinct elements 0 to n minus 1. For example, 1, 2, Okay. uh, you are given n and k, construct a permutation of p such that the following condition satisfied. Okay. Let me check it at first. Search. Yeah, it looks a good one. So 30214. So mix is 0, mix is 1, mix is 1, mix is 1 2 3 4, mix is 5. Okay, and it wants 1 as the XO. They both of them cancel out, 100 and 101, so this one cancel out, so there is 1. Yeah, got it. Question is fine. So first thing is, when will it be possible? 0 is impossible, then that makes sense. K is a really huge number. If k is greater than n plus 1, then obviously it's not possible. I want a binary value at the end. Okay, let's say I have those binary values. Let's do a smaller example. 12, 9, 12. Is it too large? 12 is 8, 8, 8, 8 and 4, 8, 9, 10, 11, 12. Yeah. So I want those values, and I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 is what? And can get mix up to 10 actually. Okay, so I want XO. XO means odd amount of ones and zeros. Yeah. So I want this value to be high. So let's say I have 9. 9 is what? 1001. So I can have 9 as the mix. Yeah, 9 as the mix. Then I want to remove this one. So it's actually not that easy. Having mix less than mix is easy, or not? No, it's not. In the end, I have to have 10. Okay, 10 is what? 8, 9, 10, 0, 1, 0. And then I have to have this value. Okay, no matter what. So I need at least 1, at least 0, at least 1, 0. I need at least this amount of XO. It's 4, 5, 6. I need 6 somewhere. Yeah. So I can just do 1, 2, 3, 4, 5, 6, 7, 8, 9. Before doing 9, I just I'll not have 6, 7, 8, 7, 8. I have stored 0, 6, 9, 3 values. Okay, I've stored 3 values. if I put 0, I'm gonna have a XOR some value. If I put 6, I'll have something plus 1. Okay. I want 1 1 0 0. Okay. And in the end I have this value. I can have some value and some that value plus 1 actually. Plus 1. So let's say I wanna have 1 1 0 0 1 1 and 0 0 1 0. I wanna have them. This one is 3, this one is 2. So I can just have 3 to remove, sorry, not 3 2, 3 and 4 remove, no, only 3 remove actually, 3 and 0 remove, 3 and 0 remove. So I can do 1 2 4 5 6 7 8 9. Then if I have 0, the mix is 3. I need 2. I'll remove 2 actually, not 3. So if I add that, it will gonna be 2 mix. Then I have to add 2. If I add 2, okay, I did a mistake. No, it wasn't a mistake. Yeah, that's correct. If I add 2, then I have to just add 2. If I add 2, the mix will be the whole thing, full thing. Yeah. So let's say I want is 1 1 0 0. Okay. 1 1 0 0. And last value is 1. Last value is 10, so 1 0 1 0. So I have to remove is only 1 0. Okay, I just want a mix of extra 2. So 1 2 3, 2 is removed, 4 5 6 7 8 9. Then 0, if I add 0, it will give me 2. Then if I add 2, it will give me 10. So 10 and 2 XOR is that value. Before that, extra. Yeah, extra. Up to 8, so n, not n plus 1. Oh, I can't print 0 actually. Um, extra, what is extra here? Extra is 5. So value goes to up to 9. 9 is what? 9 is 8001, and I need 1100. So what's the extra? Extra is 1. Is it extra? Actually, I need is 101. If I add this value to the last value, and it will gonna be that value. Yeah, I think it's correct. Yes, the first one gave me yes somehow. First value is 1001. R x equal to R, yeah, x equal to 0. Gave me R k equal to 0 actually. Still gave me yes. Not equal to 0. Let's try. Wrong on previous one. Nice. Wrong answer token equal to 0 doesn't discuss 3. Why it gave me 0 0? This gives 2 1 1. Yeah, it's giving 0 0. It has 0. Makes sense. Number 3. Yes, this number 3. 3 0. Wait a second. It was 0. 0 1 2. Can you print it? 1 2 0 3. 0 1 and next one is 1 1 0 1 1 1, because sometimes it becomes 0 actually. If k equal to 0, continuous printing is an option. If I got 3 somewhere, I can't have 3 again. Let's have 1, okay. At least I need 3 possible candidates, 1 1 and 1 0. At least 3 values. If I have 0, I need at least those 3 values. So let's say 1, I need what? 1 2 3. So I have to miss 0 1 2. Okay, so let's say I have all the values, then 0, get 1, then added 1, so got 2, added 3, added 2, got 3. Okay, if that's the case, if that's a 0, if that's a non-zero, then that's that. Let's create that actually. Okay, that's 1 for non-zero. Non-zero is doing that, what I've done there. If the extra is smaller, extra smaller than n, then that's, sorry, less than and it's gonna happen no matter what. Those the extra value less than equal to n is valid. Okay, and for extra value, let's say my extra I need 5 mix, so I'll remove 4 actually, so that was a mistake, because 1 2 3 4 missing, 5 6 7. Okay, so I added 0, it becomes 5, then can add 4. So extra, I have to do extra minus 1. Okay, so first option is ex minus 1 greater than equal to 0 and less greater than equal to 1. Yeah, if I remove 0, greater than equal to 0 and less than equal to n minus 1. Okay, that's the first point. Another option is it's a 0, k is 0, so I can do 0 1 2 trick. Okay, 0 1 2 trick, 0 1 2 trick. No, it's not valid actually. 1 1 1 0 1 1. Let's say I have n is my mix. Let's say 1 0 1. I want to make it 0, so I need this value to be removed, combination of two values. If my mix is 5, if I divide it by 2, I'll get 4 and 1. I can do that for 0. Okay, so k equal to 0 is solvable by that logic. And next is what? So I'm saying if x trace n minus between something is possible and 0 is possible, is there anything else possible? I'm really confused. Can I go greater values? X, sorry. Yeah, greater I think possible because it can be combination of multiple values actually. My mix can be something max of n. If I want something more, yeah, it should work actually. Extra should work. Yeah. So if let's do a minus 1, x greater than equal to less than n, and x greater than equal to 0. If that happens, okay, that's the ex part. Now the 0 part. Zero part, okay. I have to divide the value into two segments. Okay. If that's an even value, k is 0. I have to divide n. Yeah, I can divide n. What if every value is 0, only 1 is there? It's a power of 2. If it's a power of 2, eight. Eight is I want 12. For 12 I've added up to 5, then 12, 5, then 9. 5 is 9 is 8, 9, 5 is 101, so I get 1100, 8, 12. Yeah, that's correct. If k equal to 0, n is what? N is 4. That's a power of 2. So that's not possible. If k equal to 0, should I make it bit set? N can be up to 25. Well, let's make 5 each. Bit equal to n. If bti x equal to 0, y equal to n. Receive nothing if k equal to 0. Yes, first one got yes, but that's not true, obviously. I think I should create a check option. printing that much. Am I printing somewhere else? That's obviously doesn't match. K is 0. I got 1. K is 0. Second case should give only 0, but what happened there? One, yeah, so it's 3. Second case, it's giving me 1. Yeah, that's 1. So why n is 3? You're saying n is 3. But first case, second case, third case, first case, second case is giving me 0. Yeah, it makes sense. Okay, first case, second case didn't go in. Third case have an answer. Third case is what? 0. So it goes there. Oh, let's see. Let's see. If that happens, just push back. Just find those values. Considering x and y. Yeah, it looks promising. So I got my x and y. I have to remove these two parts from there. if I equal to x not equal to x and I not equal to y minus 1, if both are true, then answer dot push push back I if x if x minus 1 less than equal to 0 and x minus, let's just do x minus minus y minus minus. Four and 9. I should get 5 and 9 actually. X minus minus. It should be 4, yeah, 4. If okay, 5 should be missing. Okay, here's the fault actually. I'm dividing x and y. Okay. Then I have to put 0. Then I have to put 0. Then I have to put x, then y. Always like matches. It has 0 already inside. How? It doesn't make sense. I've cleared out the size. And it has 0 inside. Starting from 1. Zero one, 1. I'm inserting only 2 values. 0 1. Then y went answer size is 0, obviously. 1 to n minus 1. Becomes 0. 0 0 1 2. Somehow I'm inside. Okay, it makes sense. I have inserted that value and minus 1. Inserted 0 0 1 and 2. Zero one two. No, yes, yes, no. No, yes, yes, no, yes, yes. Took me a lot of time. You see the standing. 2000, it's good enough actually. Yeah. Wrong answer on register. Checker function is spot on actually. I don't think this first function is also really good. For 0. Nice. Kinda ঘুরা দাও. So what's sound version? K can be, M can be. Okay, that's won't be a problem. It got y at this is 2. A equal to 0. Answer equal to 0. That's the size here. Do I think that's a mistake. I wanna remove. Okay, I do think that's a mistake. It's taking way too long. 1 and 2. Zero. Then 2. Added 0. Then adding 1. Then adding 2. It should give me 0, 1, 2, 2. If I why it gave me 0, 1, 2, 2? Not seen at -1. Card 0. Inserted 1. Inserted 2. Then going to insert n minus 1, that's also 2. But that's not possible. Such a no, yes, yes, no, yes, yes. give another try. Let's see. I feel like it is gonna get wow. Yeah. So my last mix will always gonna be n. Okay, if I divide n into two segments, and try to make a mix, one four one eight. Actually, those are possible. I need 12. Okay, 12 is what? 1100. So at this point I got 1. So I got 1. 1 and 8. Okay, it was a mistake. I need 12. I need 12. If I divide it by 2, I want this part from somewhere and that part from somewhere. So I got that value. Okay, it's a mistake. So I want this value, okay. But I'll also get n. N is 9. 1001. So eventually I'm getting this value no matter what. But I want to get this value. Missing an extra part. The missing value is 5. I'm getting 5. For 0, I have the answer. For ex less than something, I have the answer. So I need ex greater than something. If ex is greater, I have to go with a combination actually. That's a 1 1 1. Now let's not focus on the ex. Let's say I have 1 1 1 at my equal to k. I have, let's say, 1 2 3 4 5 6 7 up to 6. Let's say up to 5. Okay. 1 1 0 1 1 1 0 0 1 0 1. Okay. I want 1. So let's get 1. I want 3, so let's get, sorry, I want 1 here, so let's get 1 here. I want 1 here, let's get 1 here. I want 1 here, let's get 1. So if I take the power of 2's, it should be good enough. This is the power of 2's. If I don't have the power of 2, it's impossible to create actually. Yeah. Okay, if that's a 0, what happens? So I need the 0 part actually. That's the 0 part. Let's have all of them actually. It doesn't hurt. It's equal to P. If BTI let's say 1, 2, 3, 4. I want the value to be 1. I've added everything 1, so 0. Yeah. For 12 is 1 1 0 0. Okay, I'll have 8 and and 4. So it should work actually. One, two, three, four, five, six, 7. Then it got 8. Sorry, it got 4, then 8. I got the value, but the problem is everything looks fine. Let's give the check function last check. Ooh. Okay. Still risk isn't gone because it was a weird combination, of course. Nice. Still 2000. Okay, you are given to integer n and m. You need to construct an integer array of length and that satisfy m restrictions. Each restriction can be represented by a tuple 0 ij such that 0 belongs to 1 2. Okay, if 0 equal to 1, okay, let's call it lam o equal to 1, then sum ai aj must be non-negative equal to, then sum be negative. Each test contain multiple test cases. The first line contain t n and m represent the length of the array. Needs to, okay, you are given n and m. You need to construct an array of length and such that m, okay, m equal to n into n plus 1, okay, n square. M line, okay, must not restrict, is greater than m over all 10 to the 6. For stress case, if such exists, output doesn't exist, output no, other output yes, and the array. Okay, if 1, then sum non-negative. Okay, 1 1. Okay, size is 1, and I'll do first two values. Sum is non-negative, so it can be any positive value. Okay, what is the value of n? N only 1000. There's, okay, there is two values, 1 and 1, has to be positive, so it's a positive value. 1 and 2 has to be positive. 2 and 2 also positive. Okay. Again, two option. 1 and 1 positive, 1 and 2 positive, 1 and 2 negative isn't possible, violating. So, and the array can be up to what? Up to 1 in 9. So I'll fix the values in which position is positive, negative at first. Okay. Then I'll see in which positions it's saying positive, negative. Let's say this position, positive and negative combination. Okay. This two creates a positive value. Okay. If this two creates a positive value, this value P has to be greater than N. AV is greater than N. If that's the negative value, that's greater. If they creates chain negative, I need how many dependency are there. It has the max dependency. Okay. It has max dependency. Let's say 2 dependency. So N has to be at least -2. So it has to be minus plus 3, and it can be 1. I'll start from the max dependency with max value, then I'll go to the next dependency and see all the dependencies. If there is another N which is greater than this one, P is depending on N. P, I'm saying N is greater than, if I add them it's negative, if I add them it's positive. So there's another N. If I add them, that's positive. If I add them, that's negative. Okay, so I'm saying N is greater than P, P is greater than N is greater than P, and P is greater than N, which just violates the rules. Then that is impossible. Yeah, that's impossible. if it creates a chain, it has to break somewhere. It has to break something like that. If I want to do it in O of n, it will be a graph problem, I guess. I have n square option, so let's make them 1 minus 1 1 minus 1. Okay, and I'm saying that. Okay, let's check the first rule for this position. First rule for this position, this should be 1, so let's do plus 1. Second is, let's say, second operation, this 2, it should be positive but getting 0, so it should be negative getting 0, so it would be minus 2. Then there 2 0, so that's yes. Again operation 3, so valid, yes, 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 no change, so that's good. I can do n square. if sum is less than 0, sum is less than 0, if flag L greater than equal to flag R, flag L plus plus, else flag R plus plus, and OK equal to 1. Else if a equal to 2 and sum greater than equal to 0. If L is less than R, if L is less than equal to R, okay. X equal to n plus, it's a 10, and x minus minus. Not okay. Ouch. Something weird is going on. Oh. Yes, 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 no, yes, no. Oh, M is 10 to the 6. So it will gonna get TLE. I'm working on M, so it will gonna get TLE. Yeah. There's a huge chance it will gonna get TLE. N is 1000, but M is 10 to the 6. Yeah. It will gonna get TLE, no matter what. Yeah. So I'm running on M. Yeah, clearly makes sense. I'm gonna run on N. So I have some positions, I have some operations to do. So I have two options. some values are greater than, some values are less than. Okay, yeah, I got the point how to solve it. But some values greater than, some values less than. Okay, and let's say 4, 5, 3, 8, something. Most max, most mean among them. Doing an operation. I'm doing operation on n, and that's not correct. I wanna do operation on n. Some values are max, some values are mean for a position. For this position, some values are max, some values are mean. If I can see the most max position or most mean position, if those are a map, I can have at most n operation, n update, yeah, at most n update. At most n updates. I'll find the value. At most n updates. If the position is common. let's say I have this position 1 2 3 4, 3 is inside here, and I've decreased 3 -1. I've done -1, so I'm gonna check is the value inside there or not. Most maximum and most minimum, I mean, those two. Most max, most min, yeah. Should I run it 30 times or 40 times? It was 6, 7, 8. I can run up to 100 times at max. It has a really high probability it will gonna get wrong answer. Yeah, makes sense. If m less than equal to what? 10 to the 4, 10 to the 5, 1, 2, 3. Yeah. X equal to n plus 2. Still a wrong answer. So m is really high, but it didn't touch what. Let's see what was x. If m greater than equal to, let's say how much I can go. M is 10 to the 6, I guess. Yeah, 10 to the 6. So ten to the 4 feels good actually. 4 second. Yeah, 10 to the 4 feels good. X equal to 70. Obviously, it will run. And 3,000. Wow. Far more than this fellow. 5. M is really high. So I have 4 seconds, okay. 4 seconds for 1 root of our answer. 2000. But oh, it's n into m actually. If m greater than equal to 4e8. I'm getting huge penalty. Wow. TLA. In this case, it didn't give me TLA, but in here it gave me TLA. Minimum of 1 plus 5. It shouldn't be a problem actually. Six. Oh. Do E 3H. Let's go for the extreme 4H. Okay, and or maybe let's do 3H again, and 10 to the 6, 7, 8. So I can go up to 100. Two six is too much, I guess. Two eight. Okay. Roman plate is 12, yeah, makes sense. so it needs an operation at least. It was 6 into 1000. 7, 8, 9, 10, 9. 10x more. 10x more, so 1e9. Really. Makes sense. Only got TLD and test case 15. So I'm decreasing. Okay, I can also remove some operations. If not empty, comma should run on VP2.
max operation. Yeah. If A
Getting a huge minus, but whatever.
See you then.